In this section, we will introduce an important concept, the concept of profit maximization. So one of the main goals a firm has is to maximize profits. But how exactly does a firm maximize profits? Well, recall that our profit equation is profit equals revenue minus costs. So keep this in mind as we go through the next few slides. So let's evaluate profit maximization through the use of an example. So let's suppose we consult for a company that makes generic laptops, and they are sold at a big box store. And also, we'll suppose that the price that is charged for these laptops is $300, and we have an increasing marginal cost. So graphically, we can represent this with these two lines here. So we have the horizontal price, and we have the increasing marginal cost. So as quantity produced increases, the cost also increases. So take a look at that point of intersection between price and marginal cost. If you go to the left of this point, we see that price is above marginal cost. So the amount of money you're bringing in for that unit is greater than the amount that it costs to produce that unit. But on the right-hand side of that intersection point, it costs more to produce that additional unit than the price that you're bringing in for selling that unit. So this leads to a conclusion. We'll want to produce up until the point where marginal cost is greater than price. So beyond that, it's not worth it. So to summarize, we're going to produce where marginal cost equals price. If we produce where marginal cost is greater than price, we're not bringing in enough revenue in order to cover that unit cost. So we can also say marginal cost equals marginal benefit. So marginal benefit is evaluated in terms of the dollar amount that we receive from selling that unit. We can also evaluate this using calculus. So just bear with me on this slide, it's a little heavy. But let's just start with the equation for profit. So remember, profit equals revenue minus cost. And revenue equals price times quantity. And cost, we're just going to represent with a generic cost function. So a function C is a function of Q. So in order to maximize, remember, we take a derivative and we set that derivative equal to 0, and then we solve for Q. So what we're going to do is take the derivative of our profit equation with respect to Q and set it equal to 0. So on that line, third from the bottom, we have d profit over dq. So our derivative of profit with respect to Q equals price minus the derivative of cost with respect to Q. Remembering that cost, if we take the derivative of it with respect to Q, that just gives us the marginal cost. So that expression simplifies to price minus marginal cost. Setting this equal to 0, we get price equals marginal cost. So the Q that solves this expression, we call that Q star. So that's the quantity at which we want to produce in order to achieve maximum profits. So let's go back to our laptop example. So let's suppose that our cost function is 500 plus 20q squared. So creating the profit equation based on that cost function, we'll take our price of $300, multiply that by Q, that gives us our revenue, and then we'll subtract off the cost. Graphically, this profit function looks like an upside down U. So we see that we kind of have a maximum somewhere around the 7, 8 point. So quantity of 7 or 8, somewhere in there, that would give us our maximum profit. So we can actually calculate what that Q specifically is and how much the profit will be at that point. So let's go back to our profit equation. Remember, this is 300Q minus cost, which is 500 plus 20Q squared. So our derivative of profit with respect to Q gives us 300 minus 40Q. Setting that equal to 0 and solving for Q, we get a quantity of 7.5. So in order to solve for the actual profit, we're just going to take that Q star, sub it back into our profit equation, and that will spit out our maximized profit. So in this case, we'll get 625.